Peace be upon you. Welcome to all my students in Prep 1 with you, Mr. Mohamed Omar. In this video, we will make a revision about Unit 1, and the first term is the set of rational number. So let's start. Okay, example number 1. Represent each of the following on the number line. Letter A, -7/4. Let's represent -7/4 on the number line. Okay, to represent -7/4 on the number line, first of all, we draw the number line. We know that this is the number line, 0 in the middle, and we write the positive number in the right hand side to positive infinity, and we write the negative number in the left hand side to negative infinity. First of all, we put all the number on the number line with the same denominator 4. So 0 means negative or 0/4. Yes, 0 equals 0/4. And then we write all the number in the right hand side as follows: after 0, 1/4, then 2/4, and so on. And also we write the numbers in the left hand side. After 0, -1/4, -2/4, and so on. But we notice that the fraction 7/4 have a negative sign, so we should complete this is number in the left hand side to reach to -7/4 as -3/4, -4/4. -4/4 means -1. Yes, then -5/4 and -6/4, then -7/4, and put a circle. Now we represent -7/4 on the number line, but we know that we should write or drawing the number line by using a ruler, not by using our hand, and make the same distance between each two numbers in the number line. Okay, number B, 1 and 1/5. This is mixed number, so first of all we should convert the mixed number to fraction, and then represent the fraction on the number line. So 1 and 1/5 equal 1 times 5 equal 5. 5 plus 1 equal 6 over the same denominator 5, 6/5. This is the fraction. And this is the number line, 0 in the middle and infinity, negative infinity. Okay, now we should put any number on the number line with the same denominator 5. So 0 equal 0/5, and complete 1/5, 2/5, again 3/5 to reach 6/5, and then put circle, and now we represent 6/5 on the number line. We notice that if the number is positive, we represent on the right hand side, and in the first example the number is negative, then we represent in the left hand side. And letter C, try to solve it by yourself. This is homework. Example number 2. Write the correct sign more than or less than or equal to. Letter A. Every positive rational number. Sure, every positive rational number more than 0. Okay, letter B. Every negative rational number also less than 0. Letter C. The absolute value negative 13 over 2 more than or less than or equal to the mixed number 6 and a half. We know that the absolute value remove the negative sign, so the result is the absolute value of negative 13 over 2 equals only 13 over 2, and the mixed number 6 and a half equal what? Equal, to convert it to the fraction, 6 times 2 equal 12, 12 plus 1 equal 13 over the same denominator 2. Now we notice that the two side 13 over 2, so the result is equal to. Okay, letter D. Negative 9 over 3 equal negative 3, so negative 3 equal to negative 3. Letter E. The absolute value of 15 over 2, or the mixed number 7 and a half. The absolute value 15 over 2 equal the same number 15 over 2, and the mixed number 7 and a half equal what? Equal also 2 times 7 equal 14, 14 plus 1 equal 15 over the same denominator 2, so the result equal to. Letter F. We know that the point above the digit means the digit is repeating, so 0.5 equals 0.5555 and so on, and by approximating to the nearest 10, so the result is 0.6. So 0.6 or 0.5? Yes, 0.6 is more than 0.5. Letter G. Negative 3 over 2, the absolute value of negative 3 over 2 equal 3 over 2, and we know that 3 over 2 more than half. Example 3. Write two rational numbers lying between number 1, 1 over 3 and 4 over 5. Okay, to get two rational numbers or more lying between the two fractions 1 over 3 and 4 over 5, we should make two steps. Step number 1, make the two fractions having the same denominator. So 3 times 5 equal 15. 15 in the first denominator and 15 in the second denominator. Then 5 times 1 equal 5 and 3 times 4 equal 4. Sorry, 3 times 4 equal 12. Okay. Step number 2, count from 5 to the number 12 and then choose any two number. So 5, after 5, 6 over 15, 7 over 15, and so on to 11 over 15. But we need only two numbers, so we choose 6 over 15 and 7 over 15. Number 2, negative half and 1. We know that 1 means 2 over 2. So negative half and 1. 1 means 2 over 2 and negative half. We found the two fraction, negative half and 2 over 2, having the same denominator 2. Let's count from the number negative 1 to reach to the number 2. After negative 1, 0 over 2, then 1 over 2. And this is the two rational number 0 over 2 and 1 over 2 lying between negative half and 1. Number 3, 0.3 and 4 over 5. We know that 0.3 equal what? Equal 3 over 10. Okay, 0.3 and 4 over 5, 3 over 10 and 4 over 5, and 5 times 10 equal 50, and 50. 5 times 3 equal 15, and 10 times 4 equal 40. And now we have a lot of numbers lying between the two numbers 15 and 40. Let's choose any two number after 15. For example, 16 over 50 and 17 over 50. Example 4 complete. Number 1. Between each two successive integers there is an infinite number of rational numbers. This is number 1. Number 2. The opposite rational number 1 over 3 on number line is negative 1 over 3. Number 3. The number of integers lying between the two fractions 5 over 7 and 8 over 11 are, by using calculator, convert each two fractions to decimals. We found the first fraction equal 0.71 and the second fraction equal 0.72. So we can't find any two integers, any integer lying between these two fractions. So the number is 0. Okay, example number 5. Write the rational number that equal 3 over 4 and the sum of terms is 28. We know that 3 called the first term and 4 called the second term. So we need to find a rational number equal 3 over 4 and the sum of the first term and the second term equals 28. So what is the rational number? Equal 3 over 4 and the sum of its two terms equal 28. Let the two terms of this fraction is 3x and 4x, and we should find the value of x. And in the given, the sum of these two terms equal 28, so 3x plus 4x equal 28. Now this is normal equation. 3x plus 4x equal 7x equal 28. Now we can find the value of x by divided by 7. 7 divided by 7 equal 1. So the value of x equal 28 over 7 equal what? Yes, equal 4. So the value of x equal 4. So the fraction is 3 times 4 equal 12, and 4 times 4 equal what? 4 times 4 equal 16, and the sum of 12 and 16 equal 28. Okay, example number 6, using the addition properties in letter A, 5 over 8 plus negative 3 over 4 plus 3 over 8 plus 3 over 4. We notice that the two fraction 5 and 8 and 3 over 8 having the same denominator 8. Also the two fraction negative 3 over 4 and 3 over 4 having the same denominator 4. So the first step, we use the commutative and the associative properties. 5 over 8 plus 3 over 8 in bracket plus negative 3 over 4 plus 3 over 4 in another bracket. So this is a step called commutative and associative properties. Second step, negative 3 over 4 and positive 3 over 4 equal what? Equal 0. This is additive inverse. Plus 5 over 8 plus 3 over 8 having the same denominator 8, and 5 plus 3 equal 8. So the second step called additive inverse. Okay. Step 3. 8 over 8 equal what? Equal 1. 1 plus 0. 1 plus 0 additive identity. So 1 plus 0 equal 1. And this is a step called additive identity. So now the result equal 1, and now you can solve letter B and letter C by yourself as a homework. Example number 6 or number 7. If x equal 5 over 6 and y equal negative 1 over 3 and z equal 1 over 2, find number 1 x plus z. Okay, let's solve. X equal 5 over 6, 5 over 6 plus z equal half, 5 over 6 plus half. We know that we should put the two fraction having the same denominator. So 2 times 6 equal what? Equal 12. 12 in the first and 12 in the second. And then 6 times 1 equal what? 6 times 1 equal 6, and 2 times 5 equal what? 2 times 5 equal 10, and then we make addition. Then we put 12 in the denominator. 10 plus 6 equal 16, and 16 and 12 in the simplest form. 16 divided 4 equal 4, and 12 divided 4 equal 3, so the result 4 over 3. Okay, letter B. Letter B is x minus y. x equal what? 5 over 6. And y equal what? Negative 1 over 3. So let's solve. Equal 5 over 6 negative 1 over 3. We notice that we have two negative. Negative times a negative equal what? Equal positive. So the result 5 over 6 plus 1 over 3. Okay, let's make the two fraction having a common denominator. 3 times 6 equal what? 3 times 6 equal 18. 18 here and 18. 3 times 5 equal 15, and 6 times 1 equal 6, and then we put 18 in the denominator. 15 plus 6 equal what? Equal 21. Okay, 21. Now we put this is fraction in the simplest form. 21 divided 3 equals 7, and 18 divided 3 equals 6. So the result 7 over 6. And now we can solve letter C and letter D as a homework. Okay, now we are finished our revision in Unit 1. I hope everyone is benefit, and see you later in other videos.